Hi everyone, and saturating you with videos this week, but you seem to be able to take it, so I'm going to keep going. Um, so this video, I would call it um, meaning, which we've been talking about, the subject of meaning, and the idea of the random. So what I want to start out by saying is that it's my experience as a scientist, but I'm sure that you have noticed that we very often find ourselves in the position as scientists of saying that something is random, or that it just happened. This just happened to be so. For example, we could say, well, the Earth just happens to be in the habitable zone of the sun, and that's why we could be here. So in a sense, it's not exactly, we're not exactly saying that it's random, but in fact, we do end up using that word random, or it's just by chance, very often. And what I want to say is, there are some really good reasons why we end up saying that a lot, obviously, and it's not the I don't know, maybe it appears like an innocent statement. This is just random. It's just a random process, or it just happened. And I don't think it really is as innocent as it sounds. And so we're just going to talk a little bit more about that. But first of all, you watched the film Big History, and you noticed that they use the term lucky break frequently, well, at least 8 times. And for major events that if they wouldn't have happened, we wouldn't be here. And so essentially they're saying that these things just happened. It just happened. And the same thing with in the video of George Ellis I sent you. There they actually discuss this, but it just happened. Why does the universe have the constants that it has, which have to be within very narrow realms? Some of them, at least, have to be in very narrow realms for there to be any possibility of life in that universe. Okay, so one of the three explanations that George Ellis gave was, well, it just happened. And when things are very, very, very improbable, such as in this case, according to current laws of physics, to have constants that would lie in those narrow ranges, is extremely improbable, because we have no reason to there's no science that we know of that would cause them to actually lie within those realms. Then so we then start to think in terms of, we don't have a reason why they lie in those realms, then we start to think in terms of probability. They're not explained by current laws of nature, so they must have just happened to be. If they're not explained by laws of nature, then they must just have happened. It must have just happened to be. Or, and in that particular video, what we'll do is we'll create something like the multiverse, right? So now we have to have billions of universes, each of which at random, by chance, would have their own values of constants. And by chance, one of those universes would happen to have the properties needed for life, the constants needed for life. So, and what I want to say is that these statements are forced. We're forced into those positions, right? We're forced into those statements as scientists because of our fundamental assumptions, right? So, and then the other significant example of this has to do with biological evolution, where we are similarly forced into saying that there's at least a random component in biological evolution, which is the mutations of genes, which are then selected for by survival of the fittest. So we're forced into this position of saying that these things are random. And yet, many scientists can't help but note that evolution appears to have a trajectory, right? It goes from the simple to the complex. Over time, it has a trajectory. Now, why it would have that trajectory, given that mutations are random, is not entirely clear. So this trajectory of the entire universe from the simple to the complex is something that's just happening, but these trajectories we are forced into the position of describing them as being results of random processes. And these assumptions, the assumptions which lead to these conclusions inevitably are those which we talked about last week in the cartoon video, right? Which is that we have bottom-up causation, basically, and there's a metaphysical stance which science takes, which is that the universe cannot be directional. It's because we're invested in the assumption that the universe is entirely mechanical. Now, it's not like mechanical things can't have directionality to them. They can. And so the aversion to directionality is doesn't actually make that much sense. But the aversion has to do with, we do not want there to be supernatural explanations for anything. So the standard defense then is things are random, or they just happen. And what I want to say is that such a statement, appearing innocent, it really isn't. It is a metaphysical statement. And Simon Conway Morris, in the interview that I sent you today, says as much himself. I mean, these things are metaphysical statements. Science is here caught making a metaphysical statement. Now, clearly, if we say something's random, what we're saying is it doesn't mean anything. There's no significance to it. It just happened. Okay? So meaning, significance is denied by science. That's a metaphysical statement. It's a comment on meaning. And really, if science doesn't want to make metaphysical statements, then we should leave it alone, right? We should say, well, this is what happened, and we don't know if it has any meaning or significance at all. We don't know that, and we can't comment on that. But we can tell you what happened, and we just can describe to some degree how it happened. But we're not going to make any comment on its meaning or significance. But we don't do that. We have to make a comment on its meaning or significance. And it's particularly clear in these cases that we've talked about. Why do we have a multiverse? Why do we need a multiverse? We've got a universe that has fine-tuned constants. We can't explain it any other way, and we don't want it to mean anything. So we have to say that there are a billion multi-universes, right? So our fundamental assumptions force us into these kinds of statements. That's what I'm saying. And maybe it's okay. Maybe it's all okay. But we're really as scientists not saying that up front. We're stepping out of our territory when we do things like that. And it is also forcing us into our own kind of corner. So it's, in my view, time to start getting really honest and philosophically grounded about some of these things that we do. And stop pretending that we know that something is random. I just want to say this for a start. The word random, first of all, it's an idea, right? Random is an idea that something can be random. The test or tests by which you prove something is random are quite vigorous and almost never applied and almost never passed. So when we can say that something is formally random, formally in terms of a formal sense, that's actually, we don't often get to do that. So what happens is we say things are random based on theory. So things are theoretically random. So the decay of an atom, for example, of an isotope, when the decay happens, is theoretically random. So it's random because it's theoretically random. We don't actually know if it is random, really, and then of course we have things like random number generators, and it's hard to know if any of them are truly random, and certainly computational ones aren't random because they will repeat given a long enough sequence. So and then we have physical random number generators, and I wanted to tell you about the Global Consciousness Project. You can look that up. And this is a project which is originally out of Princeton, and it's where random number generators are located. I think about 60 located around the world. The thing about random number generators is if they're truly random, the numbers or the signals that are coming out of each one, if you correlate them, they shouldn't be at all correlated, okay, because they're random. So there should be no correlation between the outputs of these two things. So we can do correlations between these 60 global random number generators, and they're very carefully chosen state-of-the-art random number generators located around the world. What they do in this global consciousness network is they correlate the 60 random number generators, and they find that there are significant periods of time when they do correlate. And so we have to say, well, then they're not being random at that time. They're somehow in sync, correlated, or anti-correlated. And these correlations they have observed coincide with particular events. And 9/11 was one where they were actually doing this project, and the correlation went way off the charts prior to that event, and then during it, and then died away afterwards. So then again, there's this sort of suggestion of an influence between consciousness or something else and these physical mechanisms, and the physical mechanism within these random number generators are based on quantum physics. So so it's not entirely clear that there is, and I just want to say this, though we have formal mathematical definitions of random, it's not entirely clear that such things actually exist in the real world, that randomness actually exists. And then if you think about it even more deeply, to even talk about something being random as a scientist is a weird thing to do, because we as scientists tend to believe that things are deterministic, which means that nothing, if things are deterministic, then they're not random, okay? So because they are determined by prior events. And we've got Pascal's demon, which said that if this demon had a sufficiently large brain, that he knew the location and properties of everything in the universe, then the universe would become known. There would be no uncertainty. Well, now with quantum theory, to some degree, there is a kind of uncertainty that's sort of built into things. But nevertheless, scientists think that the universe is largely deterministic. So what is that? Well, if it's deterministic, then how can we say it just happened, or it's just random? Obviously, there are reasons why something happened, and in this case, we would think there are physical reasons. So then we have to imagine causal mechanisms that would, with determinism, produce things that appear to be random, and that we can do. But the whole sort of thing is odd. So what I like to do is to put a question mark by that word random, and we use it too lightly. We don't think deeply about it, and we ought to, because it's used as a defense, and I would say prematurely by science. It's used as a defense against all who would say that there's something like intelligent design. And in doing so, we force ourselves into a kind of blind alley, I think, where we're coming up with explanations for things that might not be appropriate, and we're making a metaphysical statement. So to walk around the world thinking that things can be random, I just think that creates an interesting world, and it creates an interesting shift if you walk around the world and think, well, maybe that idea is just an idea, and nothing that happens is random, or even can be random, including our own existence. But that's something that would freak out most scientists, and it would have freaked out me at some point. But I think we have to challenge these ideas and think about them in all ways, including philosophically. And there's at least a sufficient reason to go into this concept and say, well, I don't think we're being as careful and as honest as we need to be about some of these ways that science is using these terms. And to me, personally, so now really just going to a personal level, it's this concept that things can just happen, that they just happen, is definitely a metaphysical statement. And it creates a very weird worldview. It's coming from a weird view, and it sort of reinforces this a very weird aspect of our worldview that creates a sort of a world. It does create a world that is, and it intentionally does create a world that's devoid of meaning or significance. Okay, and as Ken Wilber says, and I may not have sent you the introduction to sex psychology and spirituality, but I will if I haven't. Then as he says in that introduction, this is a childish explanation, and that clearly something else, there is significance here, and something is going on. So, and I think if we're going to be adult about it, then I do think we have to say, hey, there's plenty to be explained here. And we can't just toss it away by what he calls oops. Oops, it just happened. He can't be explained by that. And this obviously dovetails into the whole discussion of meaning and significance, which is science is constantly making statements that are statements of meaning. And we're not aware of it. It's underground, it's subtle. It comes from the assumption of no meaning, not from the proof of no meaning, or the assumption of no significance, not the proof of it. And we take it on. We take it on into our worldview. With the iceberg metaphor that we started with, these things go into the root of the iceberg beneath the water. These things are living in there. And when we say things like, well, we're the meaning makers, there's no meaning or significance in the universe, etc. When we say things like that, it's coming from the iceberg, in my view. These are not fully examined statements. These are assumptions, right? And they need to be examined. And ultimately, I think we have to say to ourselves, if we want to be really honest in this domain from a philosophical point of view, we have to, like Simon Conway Morris said, well, we actually don't know. Sorry, we don't know. And that would be honest, and that's fine to not know, right? We don't like to do that for some reason, to say we don't know. But we don't know. So meaning, significance, we actually don't know. Let's not jump to assumptions based on what lays in this iceberg that has been put there by a long project of the mechanical philosophy of our world. 400 years project that lives within us. Let's question. Well, we have a right to question. And then we have a right to say, well, we don't know. And what does that mean? It means the answer could be other. The answer could be of another kind. The world could be other than we have grown to think it could be. So these are just, for me, challenges to what we do in science. And as Simon Conway Morris said, it's like, science can't say these things. It should not say these things. And yet it does. And for the most part, especially the general public, we don't notice it. We don't notice it. It goes right in and has its effect ultimately. So, so I'm doing my part here to raise the questions, and you can tell me what you think, because you're obviously completely free to disagree with everything I just said. But we don't normally think about these things, and when we do, they start to appear weird, and for a good reason. So that's meaning and randomness. My own personal belief is that there isn't anything that's random. Yes, we in theory can generate such things mathematically, naturally, though I don't think we can, even there. But there are sort of theoretical definitions of randomness. Yes, we can do that as a concept, but that it exists, it's not entirely clear to me that it does. So, and even when we say things are random, such as in quantum theory, these things aren't actually random because they have probability distributions to them. Some things are more probable than others, and that is not. There's a random element there, but that is not a completely random process. So it's a concept that we've invented. It's come out of our minds. Does it exist in the world? Open question. Okay. I don't know if this is the last this week. I'm trying to hold off, but there's several other videos I want to make too. So hope your week's going well, and I know it's raining on the East Coast. I hope you're not being drowned, and it's certainly not raining here. If you could send some of it our way, I'd love it. And we'll be in touch soon. Okay, bye.